In the new version of planlauf terrain, we added 3 major new features. First, you can now import point cloud data and generate digital elevation models. Second, we added the local relief visualization, which highlights subtle landscape features and might be of special interest to archaeologists. And third, you can overlay the models with georeferenced images, for example, satellite imagery. Okay, let's start and generate a digital surface model from a point cloud. Click on Open and then select Point Cloud Data. You can import LAS and LIZ files and ASCII files with the file extension XYZ. Choose one or multiple files and click on Open. If you experience performance issues with big point clouds, you can reduce the number of visible points by moving the scroll bar to the right. This will not affect the number of points that are imported. You can either create digital surface models from the highest points in each grid cell, or digital terrain models representing the bare earth without, for example, trees. Please note that our building ground classification is very basic, so you should use the pre-classified ground points whenever possible. Let's create a digital surface model with a resolution of 0.5 meters. Leave the maximum spike height at 25 meters. This will ensure that the steep cliffs in the model will be preserved. If you want to smooth out the model, you can select a smaller value. You might have to experiment a little with the values to get the best result. This model of Hengistbury Head shows some sea surface with a wave pattern. You can exclude all points below a certain height value by entering the value in the field. Click on the Create Digital Surface model to start the DSM generation and wait for the Import Grid Mesh window to appear. Choose the appropriate projection. In our case, it's the British National Grid with the EPSG code 27700. Select the Fill Gaps option and set all grid points without a valid height value to 0. This will make sure that the model won't have any voids. To ensure a good rendering performance even on basic hardware, limit the number of vertices for the mesh decimation to 1 million. Check the box to include the local relief visualization in the model, uncheck the level of detail option, and click on Import Grid Mesh to start the process. If you have selected the local relief option, you can preview the data and adjust the parameters in the window. Enter the origin of the preview area and the values for low-pass filter radius and for the maximum height difference. As with the point clouds, you might have to experiment a little with the parameters to get the best result for your purpose. Local relief is also available from our mesh decimation service. Click on OK and wait for the import to finish. Save the tile file and click on New to create a new terrain file. Choose the tile file and click on OK. To change the visualization, click on More and then on Tiles and Shading. Change the contrast to 2 and click on the Local Relief tab. Notice the circular feature, which might be the remains of a burial mound, and set a pin to its center. Name the pin Burial Mound and click on OK. Pan the model and set a pin at the location of the double dikes as well. Click on the Settings button. There are 3 basic options on how to display the pins: pins, dots, or names with different length of the lines. Select the option to display the pins always in white and click OK. Now we're going to overlay the model with an aerial image. You can use common image types like JPEG or bitmap directly, and GeoTIFFs together with our GDAL interface. Please notice that the images have to be in the same projection as the model. If the image comes together with a corresponding Esri World file, the values for the origin and the covered area are automatically used. If not, please fill in these values manually. Click on OK twice and examine the model. Even if the projections of the model and the image match, there might be a small shift. Click on More, Tiles and Shading, and then on the Settings button of the image to adjust the origin and/or the size. Let's create a manual track for the fly-through. Click on Track and then on Manual Track and sketch the path roughly. You can always edit the track and add, delete, or move points. When you're done, click on More and then on Fly-Through. Choose the low-level camera profile and set the height to 40 meters and the viewing direction to 60 degrees. Camera smoothing should be 100 and the speed should be 4. We don't want to display the height profile or the track, but make sure that the pins option is checked. Click on Play Track to start the fly-through. Alright, that's it. We hope that you like the new features of planlauf Terrain. If you have any questions, please send us an email to terrain@planlauf.com.